Hello everyone, in this video we're going to learn how to find the domain of the composite functions. Now we have three steps how to find the domain of the composite functions. For example, we have f of s is s squared plus 2 and g of s is square root of 3 minus s, right? Now we need to find number one, domain of the composite function f of g of s. Number two, find the domain of g of f of s. Alright, so if you look at the first example right here, you see that g of s is the input of this composite function, right? Now the second example right here, f of s is an input of the composite function, right? Now look at this one right here. We have step number one, find the domain of the inside or input function, right? So example number one right here, we need to find the domain of the function g of s. So function g of s right here is going to be square root of 3 minus s, right? So the domain of this function g of s 3 minus s right here must be greater than or equal to 0, right? Because you cannot take the square root of a negative number. So this one must be non-negative number, right? So then I'm going to subtract 3 both sides, right? So I have negative s greater than or equal to negative 3, right? And then I need to multiply both sides by negative 1, right? So I have s. When you multiply both sides of the inequality by a negative number, you must switch inequality symbol. So this guy greater than or equal to becomes less than or equal to, right? So negative 3 times negative 1 should be 3. Alright, so the domain of the inside function is going to be s less than or equal to 3. Now step number 2, we need to construct the composite function, right? Now step number 2, we need to find the composite function, right? So I need to find the composite function f of g of s, right? So you need to start from the function f right here. So I need to rewrite the function f, right? So f of s right here is s squared plus 2, right? Now you see that you have s right here and this one s. Now we need f of g of s, right? So I have put f of parenthesis g of s is going to be right here. You see this is s, this is s, this is g of s, and this one must be g of s, right? So right here I need to replace s with square root of 3 minus s, right? So right here I put square root of 3 minus s all together square plus 2, right? Now square root of 3 minus s right here, it turns out to be 3 minus s, because we already have the domain of the function g of s. So then this guy actually turns out to be absolute value of 3 minus s, and it's going to be two different cases. 3 minus s if s less than or equal to 3, and this will be s minus 3 if s greater than or equal to 3. But because the domain 3 minus s always greater than 0, so I just pick the first case right here because this one tells us that 3 minus s is a positive number, right? and then plus 2 right here. So I'm going to simplify this one. It turns out to be 5 minus s, right? Now step number 3, we need to find the domain of the composite function, right? So look at this one. This is a linear function, right? So the domain of this linear function should be all real numbers, right? So the domain is all real numbers. Now we need to make a conclusion. Now we look at this one. If there is no restriction on the domain of the composite function, we're going to keep the domain of the input function found in step number 1, right? So there is no restriction. These are all real numbers. So we need to keep this one right here, alright? So the domain of step number 3 should be s less than or equal to 3. Or you can write this one in interval notation. It's going to be negative infinity to 3. Put a bracket right here. Or you can write this one in set builder notation. So it's going to be a value of s such that s less than or equal to 3. Alright, so you have 3 different ways to write the domain, right? Okay, now look at the second case right here. The first step you need to do is to find the domain of the input function. In this situation, the input function is f of s, right? So the domain of this guy right here is going to be all real numbers, right? Because this is quadratic function, right? Now, step number 2, you need to construct a composite function, right? So we start from the function g right here. So we need to write g of s. It's gonna be square root of 3 minus s, right? But we need g of f of s, right? So we have g of f of s. Alright? And then this guy turns out to be square root of 3 right here. Minus, instead of s, we're going to put f of s, right? F of s right here, right? And don't forget parentheses. So it's going to be s square plus 2. Alright, now I need to simplify this one. So it turns out to be square root of 3. Now I need to distribute this one. If you see nothing right here, put 1 right here. So negative 1 times s squared is going to be negative s squared. Negative 1 times 2 is going to be negative 2, right? Now you need to simplify this one further. So it turns out to be square root of 3 1 minus s squared. Alright, now the next step, we need to find the domain of the composite function. Alright, so the domain of this one is going to be 1 minus s squared greater than or equal to 0. Keep that in mind. Alright, so we need to solve this one. It turns out to be what? Subtract 1 both sides, right? So it could be negative s squared greater than or equal to negative 1, right? So I need to multiply both sides by negative 1. So it turns out to be s squared less than equal to 1. Alright, when you multiply both sides of the inequality by a negative numbers, you must switch inequality symbol. Greater than equal to becomes less than equal to, right? Alright. And then you take square root both sides, so be careful. It turns out to be s less than equal to 1 and greater than equal to negative 1. So keep that in mind. Alright, so the domain of the composite function right here is going to be negative 1 to 1. The domain of the input function right here is going to be all real numbers, right? So we look at this one right here. If there are restrictions on the domain of the composite function, we need to combine them with the restriction from step number 1. Right? If there is an overlap, use the more restricted domain or the intersection of the domain. Right? So the final domain should be negative 1 less than equal to s less than equal to 1. Right? Alright, let's move on to the next example. So, given the function f of s equals 1 minus s over 3s and g of s equals 1 over 1 plus 3s. Now, we need to find the domain of the function f of g of s and g of f of s. So, we're going to start with number 1, right? This guy right here. Now, step 1, we need to find the domain of the inside, right? Inside, which means g of s right here, alright? So, function g of s right here. This is rational function. So, the domain of this one, you need to let the denominator different from 0, right? So, domain is going to be 1 plus 3s not equal to 0, right? So, I just subtract 1 both sides. So, I have 3s different from negative 1. So, s different from negative 1 third, right? So the domain is all real numbers except this number, right? So I can write it's going to be domain is going to be all real numbers except negative 1 third. Like this, okay? So this is the domain. Now step number 2. We need to construct the composite function, right? So we start with the function f of s, right? And it's f of g of s, right? So, whenever I see s right here, I substitute the function g of s right here. Alright, so it turns out to be 1 minus 1 over 1 plus 3s. Alright, over 3 times 1 over 1 plus 3s. Alright, next one. To simplify this one, I just multiply the top by 1 plus 3s over 1. And the bottom, I need to do the same thing. 1 plus 3s over 1. Alright, so then I can simplify this one easily. Alright, so now I distribute 1 times 1 plus 3s over 1 is going to be 1 plus 3s, right? Now the second one, 1 plus 3s right here and 1 plus 3s right here cancel out. So the answer must be negative 1, so I subtract 1 over 1 plus 3s right here cancel out. So I only have 3 times 1 right here. It's going to be 3, right? Now 1 and negative 1 cancel out. So I only have 3. So I only have 3s over 3. And simplify, it's going to be s, right? Now the domain of the composite function is all real numbers because this is a linear function, right? So the domain right here is going to be all real numbers, right? Now we combine this one, so because we have the domain of the input is going to be right here and domain of the composite function is going to be right here. So the final answer must be domain is going to be all real numbers except negative 1 third, right? This is the final answer. Now let's move on to the second case. G of f of s, right? So first step, you need to find the domain of the input function. So input function is f of s right here, right? So domain of this one, you need to let this one different from 0, right? So domain is going to be 3s not equal to 0, right? So then I divide both sides by 3, so s not equal to 0, right? So the domain is going to be all real numbers except 0, right? Or you can write in interval notation, it's going to be negative infinity to 0, even 0 to infinity, like this, right? Alright, now step number 2, we need to construct composite function, right? So you're gonna start from the function g, right? So I have the function g is gonna be, now I need the function g of f of s. And I need to rewrite everything right here, 1 plus 3 right here. Now right here, instead of s, I put f of s, right? So f of s is the whole thing right here. So I need to put 1 minus s over 3 times s right here. It could be multiplied like this. So keep that in mind. Alright, so now I look at this one, I can simplify this guy and this guy right here. So I'm going to end up with 1 over 1 plus 1 minus s over s, right? So I look at this one, I see that s on the bottom right here, right? So I need to multiply the top and the bottom by s, like this. Alright, so this guy, the whole thing multiplied by s. So what do I have? Now 1 times s is going to be s on the top. Now the bottom, s times 1 is going to be s. Now s times this one and this one cancel out. So you only have 1 minus s right here. So you need to put 1 plus 1 minus s, right? Alright, so you're going to simplify. S and negative s cancel out. So the answer must be s divided by 1 is going to be s. So the domain of this composite function right here is going to be all real numbers because this is a linear function, right? Now the domain of the input function is going to be this guy right here. So you need to keep this one, right? So the final answer must be domain is going to be all real numbers except 0. Now let's move on to the next example. So I'm going to start with the first one. Alright, so the first step I need to do is I need to find the domain of the input function. So input function right here, right? So I need to find the domain of this one. So it's going to be domain. It's going to be s squared minus 1 greater than or equal to 0, right? And then I need to solve this one. So it's going to be s squared greater than or equal to 1. I need to add 1 both sides, right? So this one is going to be s greater than or equal to 1 or s less than or equal to negative 1, right? So this one right here, I need to write this one as interval notation. So it could be negative infinity to negative 1. And then you need to include negative 1. Union 1 to infinity, right? Alright, the composite function say f of g of s. So right here, you must put the function g of s. This could be right here. So it's going to be like this, square root of, now s right here should be square root of s squared minus 1. So it could be like this, square root of s squared minus 1. Alright, and then minus 2 like this. Okay, so I need to find the domain of this one. So step number 3, find the domain of the composite function. So anything under the radical sign must be greater than or equal to 0, right? So the domain of this one should be square root of s square minus 1 minus 2 greater than or equal to 0. Alright, so I'm going to add 2 both sides. So it could be square root of s square minus 1 greater than or equal to 2. Right? So I need to square both sides. So it turns out to be s square minus 1 greater than or equal to 4. Right? And then this guy turned out to be s square greater than or equal to 5. Right? Because I need to add 1 both sides. Alright, so this one turns out to be s greater than or equal to square root of 5 or s less than or equal to negative square root of 5. Now just recall, if you have s square greater than or equal to a, and then you take square root both sides, it's going to be either s greater than or equal to square root of a or s less than or equal to negative square root of a. Keep that in mind. Now if you have s square less than or equal to a, and then it turns out to be negative square root of a less than or equal to s less than or equal to square root of a. The domain of the composite function is going to be right here. The domain of the input function is going to be right here. Alright, so now we need to combine them. We need to draw a number line, right? Negative square root of 5 should be right here. And then next one is going to be negative 1. Next is going to be 1. And this one should be square root of 5, right? Now, the domain of this one right here, the input function is going to be from negative infinity to negative 1, right? And you take from everything from left until negative 1, right? And then from 1 to positive infinity, right? So you just eliminate this guy right here, in the middle right here. You don't count this. Alright, that is for input function. Now, the domain for the composite function is going to be s greater than or equal to 5. So you need to take everything from here all the way to the right. Right? You need to eliminate this one. Alright, same thing. S less than or equal to negative 5. So you need to eliminate this one. You need to take this one all the way to the left, right? And then the final answer must be this guy right here, right? This is the final answer. Now let's move on to the second case. G of f of s, right? So the first one, I need to find the domain of the input function. So the domain of the input function is going to be right here. So I just let s minus 2 greater than or equal to 0. And then I need to add 2 both sides, so s greater than or equal to 2. I leave it over there. Step number 2. I need to construct the composite function, right? So I need to start with the function g. I need the function g of f of s, right? It's going to be square root of this guy right here. I need to replace this guy with f of s, right? So it turns out to be square root of s minus 2. Alright? This guy altogether square minus 1, right? Now I need to simplify this one. So this guy turned out to be, this guy, square root of s minus 2 is going to be s minus 2. And then minus 1, right? I need to simplify this one. It's going to be square root of s minus 3, right? Now, I need to find the domain of this guy. So, the domain of this guy is going to be s minus 3 greater than or equal to 0, right? I need to add 3 both sides. So, s greater than or equal to 3. Alright, now I need to combine this guy and this guy right here. Alright, so I draw a number line. Alright, so I put 2 first and I put 3 right here. Alright, so then s greater than or equal to 2. Alright, so I need to eliminate this guy. Right, I need to take 2 all the way to the right. Right, now s greater than or equal to 3, so I need to eliminate this one. So I only take 3 all the way to the right. So the final answer must be s greater than or equal to 3. So final answer is 3 to infinity. Alright, so keep that in mind. Alright, so let's move on to the next example. So I have the function f of x and g of x right here. Now I need to calculate the domain of the f of g of x and the domain of g of f of x, like this. Alright, so what should I do? So I'm going to start from the first one right here. So I need to find the domain of the input function right here, g of x. So the domain of the function g of x is going to be 7 minus s greater than or equal to 0, right? So then I need to solve for this one, so s less than or equal to 7, right? Step number 2. I need to construct a composite function, right? So I need to start from the function f. Now I need to construct the function f of g of x, right? So I need to write f of g of x. Alright, so I need to replace s right here with g of x. So it turns out to be square root of 7 minus s over this one, square root of 7 minus s. Right, subtract 2 and plus 5, right? Now I need to find the domain of this one, right? This is a composite function right here. So this is the fraction, right? So in order to find the domain of the fraction, the denominator must be different from 0. So keep that in mind. So I have domain is going to be square root of 7 minus s plus 5 right here, not equal to 0, right? Because this one equal to 0, the whole thing is undefined, right? I'm going to look at this one right here. Because this guy always greater than or equal to 0, we find it right here, right? And when you add a number, positive number, so the whole thing is always greater than or equal to 5, right? So this one always greater than or equal to 5. Of course, this one always different from 0, right? Because it's always greater than or equal to 5. So the domain of this one is going to be all real numbers, right? Okay, so conclusion. The final domain should be this guy right here. This is the final. Alright. Alright, let's move on to the second case right here. G of f of x, right? So first I need to find the domain of the input, right? So the domain of the input is going to be right here. So domain, because the input has the fraction right here, right? So this is a rational function. So the domain of this one, you only need to let the denominator not equal to 0, right? So s plus 5 not equal to 0. And then you subtract 5 both sides, so s not equal to 5, right? So the domain is going to be all real numbers except negative 5, right? Or you can write negative infinitive to negative 5 union negative 5 to positive infinity, right? Now step number 2, I need to construct a composite function. So the composite function is going to be g of f of x, right? So I start with the function g. Now I need the function g of f of x, So right here, I need to put square root of 7 right here. I need to replace s right here with the function f of x right here. So it's going to be s minus 2 over s plus 5 right here. Right, don't forget to extend this one. Right, now I need to find the domain of this guy right here. So in order to find the domain of this one, I just let the whole thing 7 minus s minus 2 over s plus 5 greater than or equal to 0. Right? Alright, so I need to multiply this guy by s plus 5. So it's going to be 7s plus 5. Alright? Minus, now don't forget parentheses, s minus 2 over s plus 5. Right? You need to write everything under, you need to write everything in the same denominator. So this one greater than or equal to 0. Now you need to distribute this one. So you have 7s plus 35. This one you need to distribute negative 1. So it will be negative s plus 2 over s plus 5 greater than or equal to 0. Right? Now you need to simplify this one. 7s minus s is going to be 6s. 35 plus 2 is going to be 37 over s plus 5 greater than or equal to 0. Alright, now next step, in order to find the domain of this one, in order to solve this rational inequality, right, you need to let each of the linear factor right here equal to 0 to find a 0, right? So I have 6s plus 37 equal to 0, and then s equal to negative 37 over 6. Now second one, s plus 5 equal to 0, and then s equal to negative 5. Now I need to put this guy on the number line. Alright, so negative 37 over 6 and negative 5 right here. So negative 37 over 6 should be right here, and negative 5 right here. Right, on the left hand side right here, I put negative infinitive. The right hand side should be positive infinitive. Alright, now, so right here, I have 3 intervals, right? The first one right here, the second one right here, and the third one right here. Now I need to pick a number within this interval, so I'm going to test the sign, right? So within negative 5 to infinity, I pick 0, right? I substitute over here. So I see that if I substitute 0 over here, 6 times 0 is going to be 0, this guy 0, so I only have 37 over 5, which is positive, right? So I need to put positive right here. And don't forget to put line right here, guys. Put a line right here, put a line right here. Alright, so this guy positive, you keep changing the sign. You put negative side right here, and this guy positive right here. Alright, you can check it, you can pick any number right here, you will see the same answer right here. Okay, so I have positive, negative, positive. Now what I need to do is, I look at this one right here. I need non-negative, right? So it should be this guy and this guy right here. So I need to make conclusion right here. So the answer, so the domain for this one should be negative infinitive to negative 37 over 6. Now you need to check to see if you put parentheses out of bracket right here. You look at negative 37 over 6 right here. I need to combine this guy right here and this guy right here. Alright, so I need to put this guy on the number line again. For this one right here, I need negative infinitive to negative 5. I don't include negative 5, right? So negative infinitive to negative 5 and negative 5 to positive infinitive. So I need everything except negative 5 right here. Right? Now for this one, I need negative infinitive to negative 37 over 6 only. Right? I need this guy right here. And then navigate to infinitive. I need this guy only, right? So I need to include this one, right? So my final answer should be this one. This is the final. Alright, so keep that in mind. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.